There's this vast hidden network of pipes that pretty much powers our entire world. They're kind of like the arteries of modern industry, right? They carry everything from water to fuel, and keeping them safe is, well, it's absolutely critical. So today, we're going to pull back the curtain on the unseen science that keeps all of this vital infrastructure from failing. And it all really boils down to this one question. How do you stop a catastrophe that hasn't even happened yet? The answer? It isn't magic or guesswork. It's a really meticulous process of measurement, prediction, and just constant vigilance. Okay, let's dive into how it works.
So, the number one enemy in this whole battle is something silent. It's relentless, and it's literally everywhere. It's a natural process that is just slowly eating away at the strength of these industrial lifelines.
And that attacker? It's corrosion. Yup, it's basically a chemical and physical assault that works to thin the walls of these pipes from the inside out. And because this network is just so massive and so essential, letting corrosion win is simply not an option. The good news is we're not flying blind here. There is a playbook, the American Petroleum Institute's Code 570. That's the guide that engineers and inspectors use to fight back. And it makes one thing crystal clear. The foundation of this whole safety system is just meticulous record keeping. It's all about knowing your system's history, inside and out. Okay, so if corrosion is the enemy, the very first step is to understand it. I mean, you can't fight what you can't measure, right? You have to know just how fast that enemy is advancing. And that's where this key concept comes into play, the corrosion rate. You can kind of think of it as the speed limit for metal loss. It's a simple idea on the surface, but calculating it accurately is the key to, well, everything that comes next. Now, here's what's interesting. Inspectors don't just use one single measurement. To get the full picture, they actually look at the problem from two different angles. They need the long-term story, the pipe's entire life, and they also need a short-term news flash on what's happening, right now. Here's a great way to think about it. The long-term rate? That's like looking at a patient's entire medical history to see their average health over decades. The short-term rate is more like taking their temperature right now to see if they've suddenly spiked a fever. You absolutely need both to make an accurate diagnosis. So once you know the speed of the attack, you can do something that's pretty incredible. You can actually predict the future. You can calculate how much time you have left before that pipe is no longer safe to operate. And this is the tool that lets them do it. The remaining life formula. It takes the pipe's actual thickness, subtracts the minimum thickness it needs to be safe, and then divides that by the corrosion rate we just talked about. It's a really powerful piece of engineering foresight. So after all the inspections and all the math, you get a number, something like this. And this isn't just data, it's a deadline. It tells engineers they have 12 and a half years to plan for a repair or a replacement. It turns this abstract risk into a concrete, totally manageable timeline. Okay, so you have the data, but that's only half the battle. Now, an experienced inspector has to look at it, interpret it, and make a judgment call. This is where real expertise comes into play. And the process is super clear and logical. First, what kind of damage are we actually looking at? Is it uniform or is it just in one spot? Second, how bad is it? Is this a minor issue or a critical flaw? And finally, what are we going to do about it? Recommend a repair, a full replacement, or maybe just more frequent check-ins? And believe me, it's not just one type of corrosion. Inspectors are basically trained detectives, and they're looking for a whole range of culprits based on that API 570 code. They're on the hunt for everything from general thinning to tiny little cracks, blisters, and even damage from a fire. Each one tells a totally different story about the pipe's health. We started this whole thing by talking about how important records are, and now we're coming full circle, because none of this prediction, none of this decision-making is even possible without a rigorous, unbroken chain of documentation. I mean, think about it. That long-term corrosion rate we talked about, it needs the original thickness of the pipe from when it was brand new. The remaining life calculation needs a whole history of inspections. Without that paper trail, an inspector is basically flying blind. These records, they are the system's memory. And that memory, it's built from all these different types of records, and each one has a super crucial purpose. The fabrication data tells you what you're working with in the first place. The inspection history is like the ongoing medical chart. And the repair forms, they document every surgery that pipe has ever had. Altogether, they create the complete picture. So, what's the most important thing to take away from all this? It's that keeping our industrial infrastructure safe isn't a one and done kind of deal. It's a loop, a continuous cycle. You measure, you predict, you act, and you document everything. And then you start the whole cycle all over again, forever. It's a process of constant vigilance. And that kind of leaves us with a final thought. This methodical, data-driven approach to managing the physical risk of corrosion is incredibly effective. So what can we learn from it when it comes to managing other, less tangible risks in our society? From financial systems to public health. It really seems like the principles of measurement, prediction, and diligent record-keeping have power far beyond the pipes running beneath our feet.